It's a solution to the practice quiz number 2. So we are going to get another question for sketching the graph of the trigonometric function. This time the graph was not ordinary one. You see, we didn't talk about the sine x. It's the sine of x plus pi half. It shift the x. You see, we change the x into the x plus pi half. So if you change x plus pi half like a z, this is 2 sine z. So it should behave like the sine function. Okay, but since we shifted, so the sine function usually start from the origin because the sine of the 0 is 0. But since this is not x, it's x plus pi half, so you should start, that shifting is important. I'll talk about it. You can use those idea of the shifting if you have done college algebra, but in general, you don't need it really. So we do our procedure as before. Okay, so a is equal to the 2, so the range of the function, this must be, of course, between 2 and, okay, so the range of the function would be between 2 and -2. This is how much you can go up and you can go down. Okay, so that give you the range of the function. Okay, then you go for the period of the function. The period is, the sine is 2 pi, but if there is any coefficient over here, you divide it. The coefficient is 1. So the period would be 2 pi. Okay, so the range of the function between -2 and 2 and the period of 2 pi. Now the difficulty for graphing this one is that ordinary period is going to be safe and 2 pi when you would like to get one interval for one period. But since there is a shifting over here, you have to modify it. Okay, you start with the fact that x plus pi half is between 0 and 2 pi. Then you subtract the pi half, that gives negative pi half and the 3 pi half. So this would be one cycle on one period. From negative 90 degrees, okay, from 90 degrees to the, okay, from 90 degrees to the 270. So the result is, the distance, if you like, is 2 pi again. But you must start from negative pi half and try to reach to the end, which is 3 pi half. So that will make that 4 famous intervals that we talk about it. Okay, so you divide your 2 pi by 4, that give you pi half. Then you start with the negative pi half, you add the pi half, that give you 0. So you start with the 0, you add the pi half, that give you the second interval. You start with the pi half, you add the pi half, you get a pi. And you start with the pi and you add the pi half, that give you 3 pi half. You see, this is the difference between this type of problems and the original one that we did. So you pick one period between negative pi half and the, you see negative pi half, and the 3 pi half. I divide into 4. I know that each interval would be pi half. So that gives those 4 steps, if you like, 4 intervals that we usually go for it. It's a sine. So we must start with a 0, going up to the maximum, then we get the intercepts to get minimum and the intercepts. Okay, so that's like when you start from the origin.
Professor, are those
Yes.
supposed to be +2 and -2 for the max and min? Maximum
Yeah.
minimum?
There are 2. Yes, thank you.
Oh, okay.
So it's going to be 2 and -2. Yes. Okay. So this is going to be one interval. Then you can go to the left or to the right to give us another one. The one that I picked, I just went to the left. So again, you have a 4 portion, if you like, 4, just negative pi half, negative pi. It's like looking into the mirror. And then you start from here. You see, if you start again, you go the maximum intercepts, minimum the intercepts. If you look at it, this is a copy of the other ones. Some of you did it all right, and you went to the right. That's also fine. So it's very important to be able to look quickly and check this type of intervals if you intend to take, for example, calculus 1 and especially calculus 2. Okay, so that was the idea for the first one. We repeat it again. Just correct your mistakes. Okay, we repeat it again. One question, 2 parts. We give you the sine and a cosine, and we would like to give you something with the, those shifting. And some of you did the original one, then you shifted to the left as much as pi half, which is correct. And I accept it. Okay, so that was the idea for the sine. The second one is a cosine. Okay, then the range is going to be 2, -2 again. The period is 2 pi, but you have a coefficient 4. So we divide it by, that give you the pi half. Again, the ordinary period, if this was cosine of z, is going to be between 0 and pi half. But it's not x, it's 4x plus pi, there is a shifting. So you have to identify your starting point. So again, you take the 4x plus pi into between 0 and 2 pi, okay, the original interval of a cosine, or the period of a cosine. And you have to solve it for x. You see, subtract the pi, divide by 4. That gives an idea. You see, this is a negative pi 4, negative 45 degrees, and a positive pi 4. So this means you must start from negative pi half, go into the 4 sub-intervals, and reach pi 4 here. Okay, reach pi 4. How much a distance? 90 degrees, you see? 90 degrees. So we divide the 90 degrees by half into the 4, that gives us a pi 8. So we start from negative pi 4 and we add the pi 4, pi 8. This is 45 degrees, this is 22.5. So you add it to the 45, so that gives you pi 8, okay? And then again, negative pi 8, you add another pi 8, that gives you 0. You start with the 0 to the pi 8, and then you start with the pi 8, add another pi 8, 2 pi 8, which is pi 4. So again, that gives you 4 intervals that you're going to be interested in. Okay, so you have to start from negative pi 4 somewhere here, okay, and divide it into 4, pick 4 intervals, 1, 2, 3, 4. Okay, and then you know that this is going to be the cosine. Cosine won't start with the origin or won't start with the x-intercepts. So the cosine start from the top or start from the bottom. This is negative. Since it's a negative, you have to start from here. So this is your starting point, negative pi half. You go to the intercepts, then the maximum, okay, the intercepts, then the minimum, okay. You end up here. This is going to be 1 copy, and then you just go on. You can go to the right, to the left. And from the pi 4, pick another pole. You see 1, 2, 3, 4. Again, you just intercept up, intercept down. That give you 2 copy of the, okay, these famous cosine functions. So that's quickest way to do this type of operations. To get these numbers. Again, some of the shifting, it's a little bit more involved if you want to do the shifting for this one, because you have to factor out the power, and it cannot be done in one step. So this method is really very good one. You don't know what you are going to do in future. You see, with this type of ideas, and this would be so quick for you. We have a different notion in calculus. We say something we talk about arc length, means you start from here, you end up here, you want to know what's going to be the distance. Then these intervals are such important. Okay, they are going to be the keys to our operations. So that's why I just continue with this method rather than shifting. Okay, so we give you one again on the test. One of those 11 questions is going to be a sketching the graph. And identities, we are going to give you a similar one again. You see this one, identities, one of them is going to be fundamental one. You have to play with this fundamental formula that you have, sine squared plus cosine squared equal to 1. Tangent is sine over cosine, nothing complicated, just the algebra. This is the way I did it. Okay, I just distributed tangent, I just distribute these. But I use the fact that the tangent times cotangent is equal to 1. You see, so I have tangent cotangent squared. So I get the tangent cotangent is 1. So the leftover is going to be cotangent. This is another cotangent. Over here, I have the cotangent tan squared. So cotangent tangent is 1. So I break it, you see. I break it to the 1, and the leftover, everything will cancel out. Most of you substitute. You substitute the, the tangent sine over cosine. That's correct. And eventually you get the same answer. Okay. So that's the idea. It's going to be just, okay, playing with those in fundamental identities, nothing else. The second one, almost everybody got it right. That's famous sine of alpha plus beta, sine of alpha minus beta. You distribute it, you cancel it out, you get 2 sine alpha cosine beta. So we give you a similar one on the, okay, on the test. So that would be question number 2 that we repeated. Okay, this one again, most of you did it right. It's about the sine and the cosine of the double angle. Okay, so we give you the sine of alpha negative 1/3. So you need to find the cosine of the alpha. Sine of the alpha is negative. So they give you the fact that it's in the 3rd quadrant. So the cosine is negative. So we get the cosine first. Some of you missed this sign. The cosine is negative. Negative to radical 2/3 or radical 8/3. We accept both of them. For the cosine of 2 alpha, you have 3 choices. You can bring all the formulas to the test. We don't mind. So you shouldn't have any difficulty to write, to pick the correct formula. Cosine of the 2 alpha, I pick as 1 minus 2 sine square of alpha. This is one of the formula. I just substitute, get the 7/9. You have another choice. You can go with the 2 cosine square minus 1, or some of you did cosine square minus sine square. So there are 3 formulas that you can use in order to get the cosine of the double angle, cosine of the double angle. And a couple of you made a very bad mistake. What you did is, this is the cosine of the alpha, you multiply by 2, which doesn't make sense. You see, cosine of the 2 alpha is just a name by itself. It's got its own identity. You cannot do anything about these 2. The only thing you can do is they change it to the formula. Okay, it's a cosine of 2 alpha, and you don't have the alpha. If you did have the alpha, yes, you can multiply by 2. But you don't have the alpha, you have cosine of alpha. Okay, just application of that formula will give you the result. And the second part, the formula is unique. Sine of 2 alpha is 2 sine alpha cosine alpha. You have the sine and the cosine, you substitute the result. Okay, we give you 1. And I just put in the 1 in the practice one. So we check it again, make sure you got it. Okay, this next one is another one that you're going to see. It's about the sine of the sum or the difference of 2 angles. So again, we prepare for it. Sine of alpha is given to you, find the cosine of alpha, cosine of the beta given to you, find the sine. You need all the 4. Sine alpha, cosine alpha, sine beta, cosine beta. So just check it with this. Okay, make sure that you get the correct position for the numbers. Cosine of the sine of the beta is positive. You just go back and distribute your formula. Okay, and your formula is ready. You are not comfortable, okay, confident, if you like, you can bring it. Just use the correct one, substitute, get the result. Okay, it's a radical form. We cannot do anything about it. So 2 plus 2 radical 42/15 is the final answer. And that's cosine of alpha plus beta. Some of you missed it. There is a negative sign here, not positive. Remember, when you use the cosine, we have to change the sign here. Cosine of alpha plus beta is cosine, cosine minus. Cosine of alpha minus beta is cosine, cosine plus. Some of you miss only the middle sign. You substitute, you get the result. Okay, it's going to be radical form. That's fine. They are not going to be a nice number. And then application of these ideas. Again, we are going to give you one. We want to find exact value for the sine of 15 degrees. That's very famous that we can break it into the sum or the difference of 2 angles. In this case, the difference 45 minus 30. Okay, 45 minus 30. Then you just distribute it, a minus b, and you substitute the result. That's one way to do it. The other way to do it is the half angle formula. This is easy. Otherwise, you can go with the sine square of 15 degrees, which is going to be 1 plus 1 minus cosine of the 30/2. Then substitute, get this result. But this is easier. Okay, you can consider this for the half angle. You double it up. So the sine square of 15 degrees would be equal to the 1 minus cosine of 30 degrees divided by 2. Cosine of 30 degrees, that would be a little bit algebra involved, but this is much, much easier. Okay, cosine of the 75, the same. You have two choices. You see, you know that the cosine of 75 and the 15 are complementary angle. So this means cosine of 75 is equal to the sine of 15 because the sum is 90 degrees, okay? So that gives you the same result. But I just did it. You know, we can break it into 45 and 30, distribute it to get this result. They are very popular. We may give you this one again. So be prepared for it. And we put these formulas together. We give you one or maybe give you two on the test. You should check the connection, okay? Check the connection. It's a sine, cosine, cosine, sine. So this is going to be sine of a difference of two angles. You compare it with the four formulas that you have to see which one is it. This is the sine of a difference of two angles. The angles are 110 and 20. So sine of 110 minus 20 would be sine of 90 degrees, which is 1. Okay, so they give you something that when you put them together, the result is nice. You'll be able to find it. Okay, so check it, make sure that you are not going to miss it again. That was number 5. Number 6 is important. I told you it's very, a standard formula. This is the one that you are going to use in future quite a lot. What was the idea? The idea is this is cosine to the fourth. The power is very high or very large. We don't like it. In calculus, we like it, just the first power of the sine and a cosine. So anything else, you should be able to change it yourself quickly. So we go with the cosine fourth. We talk about the reducing power formula is this one. Cosine square, you write it as a double angle. Okay, 1 plus cosine of 2x over 2. So it's cosine to the fourth. We write it cosine squared and squared. Then you substitute, simplify. When you simplify it, you end up with the cosine square again. So you have to repeat this one. But you got to be careful. So you have to change it to the 1 plus cosine of the double angle. This is 2x, the double would be 4x. And just, you know, a simple simplification. 3/8 plus 1/2 cosine of the 2x plus 1/8 cosine of the 4x. It's very popular formula and there is something for it. This is cosine to the fourth. We can have something for the 6, the 8, but you know, I'm not going to talk about it, and so you better do it and get it. And you see this is going to be 2, 2, and then it's like to get a 4, 8, but you can find it. Okay, so that was the first part. We did it, and we give you something with the double angle already, just to check the formula. This is the sine. You know that the sine, the only difference is going to be 1 minus cosine. So 1 minus cosine, this is the 2x, the double angle would be 4x. Same thing, sine to the fourth, the square. So you just simplify it. Then you have to repeat it for this one. Okay, the double angle, this is 4, that make it to the 8. And the common denominator, something very similar to the other one. It's very famous problem, and we give you this one again, because this is the one that, you know, we expect you to know it when you get to those application of, the only reason that you learn this, that double angle is very important, very, very important. So those powers, cosine square, cosine to the fourth, and even cosine to the 6. These 3 are going to be used if you want to take those courses. It's not going to be used in calculus 1 at all. Calculus 2 and calculus 3 in both of them. We have 2 famous concepts. We call it, there's something we call it cylindrical coordinates, and the other one's called spherical coordinates. Now, lots of sine and a cosine involved. And these 3 formula are going to be the key for there, okay? So, you know, I just try it every day when I teach calculus 3. Okay, so that was the one. And so study this one quickly, and all of them would be repeated. I'll just put it on that practice one if we get time, even we go over those numbers. Okay, any question? So if you already submitted your quiz, in proper manner on the canvas, you should have your result. If anything is missing or something different, you email me, then we can sort it out to see what would happen to your quiz. And remember, you must be on Zoom during the quiz or the test. Otherwise, your quiz or test will not be accepted, and I'm not going to grade it because that's part of the regulation of the course. You must be on Zoom during the test, the quiz, or as you know, everybody, if you want to miss it or leave it, you have to tell me, let me know. Otherwise, automatically, we have the record of the Zoom. As soon as we are done, all the list of the attendance, everything, the Zoom will publish it. So this is not the case. You should be on Zoom. So some of you missed it. Okay, let's go back to the leftover for the inverse functions. Very nice, interesting concept. Okay, so what we did, we talked about the inverse of the sine function. So we are going to quickly to see how we're going to introduce the inverse of the cosine. It's very similar. And the inverse of the tangent, which is most popular function for, again, if you want to take calculus. It's all over the place. It's such a popular function over there. Okay, so there you are. And it's not difficult because we're already done. We explain everything in the terms of the sine. Okay, any question? So we are still in this section, 6.1, and we are not rushed to finish it because this is the one that you need, nothing else. Okay, what's the inverse cosine function? Okay, so what is the inverse? Inverse cosine function. Cosine function. Again, we talk about it. We have to check to see if that function would have an inverse. We talk about it in details about the sine. So I just briefly tell you that consider the graph of a cosine to find out if it does have any inverse. Okay, so again, consider the graph of y equal to the cosine x. Okay, and you know that the graph of cosine, this is it. If we want to consider graph of cosine, graph of a cosine, those intervals that we like. So basically this is, I suppose this is going to be 0 and this is going to be 2 pi. Okay, 2 pi, you can divide it as usual into 4 parts because the period is 2 pi. So that's going to be the 1. Okay, and you know that you go up as a positive 1, you go down as a negative 1. Okay, so this is a cosine. It's not going to start from the origin, but it start from the top because the cosine of 0 is 1. Okay, so we start from the top here, we go to the intercepts, then we go to the minimum. Okay, this is going to be a minimum. Okay, then we get to the intercepts, and at the end we end up here with the maximum, if you like. So this is going to be the graph of this is going to be the graph of a cosine in one period. Okay, that's it, in one period. If you want to continue to get it into the two period, we can, we don't need it, but we can go to the left as well. But we talked about the other night, since we want to switch x and the y, if this graph does satisfy the horizontal, horizontal line test, means if the horizontal line intersect the graph at one point only, we can find an inverse. But if you take the horizontal line, as you can see, horizontal line intersect the graph at 2 points. So this means in the natural domains, this graph, this function has no inverse, okay? So again, we note that that's one of the difficulty with the trigonometric function. Okay, note that y equal to the cosine x has no inverse. No inverse. inverse function, okay, on its natural domain, if you like, natural domain. You know, the domain is going to be already numbers, or even between 0 and 2 pi. So what we're going to do is, as we did it for the sine function. For the sine, we did it between negative pi half and pi half. So what we're going to do, we are going to pick a portion that, okay, that have the, so that the horizontal line would intersect the graph at one point only. So the portion that you can have, you see this one, if you consider your function to be only between 0 and pi, this horizontal line would intersect the graph at one point only, okay? And so this is one option. The other option, of course, is the other way around. If you pick your function to be between, okay, between pi and 2 pi, again, you have only one intersection point. But again, because of the calculus, we usually take the, or always, we define the cosine between 0 and pi only. 0 and pi. Now, why we consider to be 0 and pi? You see, this is going to be a situation we're going to have. You see, this is going to be unit circle. This is the unit circle, and this is the cosine, and this is going to be the sine. You see, when you are going to be between 0 and pi, the cosine is always positive. And I talk about it. When you use the inverse function in application, in physics, in calculus, you end up with taking the square roots of the sine squared. So if you want to have just one solution, you have to make sure that the sign is positive. Remember, for the inverse sine, we pick a negative pi half and a pi half because we want the cosine to be positive. So that's the only reason that it's no good to get the pi and the 2 pi. You see, if you go with the pi and the 2 pi, it's very bad. You can find the inverse, but the sign is negative. Then you'll be in trouble in the application in science. So that's the reason you must pick only this interval, okay? So we say, bet y equal to the cosine x is going to be, is invertible as an inverse. Is going to be, okay, it's going to be invertible on this interval, on the interval of, okay, 0 and pi. So this is where we are going to pick for the invertibility, okay? So you have to have this justification for all of them. None of the trigonometric function would be invertible or has inverse in general. You have to pick the proper interval, and you pick the proper interval by having, you know, the application in science in your mind. That's why we pick these intervals. Okay, so now we can give you the definition of the inverse cosine function. There you are, the inverse cosine. Inverse cosine function. Now it's going to be denoted, okay, denoted by y equal to cosine inverse of x. Cosine inverse of x, and is defined by, you know that we have to switch it again. So this is it. If you want to have any information regarding this function, you have to switch it. So it's going to be if and only if x is equal to the cosine of y. X equal to the cosine of y. Then you put those restrictions that we talk about it. So your restriction is going to be, so this is going to be when this x is the result, is between the range of a cosine. So your x is going to be between -1 and 1. So when x is between -1 and 1, but the y that we use over here must be between, okay, so the y must be between 0 and pi. So if y is between 0 and pi, then then your function is going to be, is defined. So the domain of the cosine inverse is like the domain of the, okay, the domain of the sine inverse. Okay, so therefore this is it. Y is equal to the cosine inverse of x. Okay, cosine inverse of x, and this is going to be the case where your x is going to be between -1 and 1. Okay, and the y is between 0 and pi. The reason I'm going to show you now some problems regarding this one, but there is a nice relationship between the cosine and the sine inverse and the cosine inverse. That's why from calculus point of view, the cosine inverse would behave very much like the sine inverse. That's why they ignore this one. I mean, we not ignoring it. It's not going to be so useful for us in that course. We rather, because if you can handle the sine inverse, then you can have this one right away. I'm going to show you what does it mean. These, those properties that we're going to use in calculus, because you can nicely write the cosine inverse in terms of the sine inverse. So it's not going to be such a, okay, such a good candidate, if you like. I'm going to show you how we, how we handle this type of problems. There is one property, but the problems that we have is similar to the sine inverse. Okay, we are going to ask a couple of them to find, but you always consider that domain. There is a couple of tricky problems, or otherwise it's the same thing. So we may ask you to give us some exact. Any question? So the problems are going to be as we did it before. When you go with the cosine inverse, if they ask for the exact, this means that angle is going to be on the unit circle chart. But if they don't say anything, you know that you can use your calculator, and you already are familiar with this type of notations. Okay, so if you go with the exact, that's it. Find the exact value. The exact value of each quantity, if you like, of each quantity that we are going to give you. The first one, for example, is cosine inverse of 0. So basically, this means you want to find an angle whose cosine is 0. So that's the meaning of cosine inverse. You want to find an angle whose cosine is 0. You know that angle is pi half. But officially, this is the way you are going to do it. Easy to find out. You are going to let, okay, always you let the cosine inverse of 0 to be something like theta or alpha. Okay, then use the definition, switch it, so that give it the fact that the cosine of the theta is equal to the 0, and quickly write that theta must be between 0 and pi. Remember, this is the condition. And you know that between 0 and pi, the only solution that you can have is theta equal to the pi half. You can check it with your table or just know it yourself. Okay, you want to check with your table. This is it. The cosine is the first component. Between 0 and pi, the first component to be 0. You see, the first component to be 0 is here. You see, 0, 1 for the pi half. So the cosine of the pi half is equal to the 0. Okay, so this is the way we're going to say to check this one. If it's going to be a negative number, it's going to be tricky sometimes. Okay, so you got to be careful. And the other thing is, you know that even the cosine of, look at this one. You see, if you move on, the cosine of the 3 pi half is also 0. Okay, but remember, You see the cosine of the negative pi half is also 0. But remember, your data must be what? Your data must be between 0 and pi. Besides, you have to have only one solution. So make sure that, I just remind you that, note that, okay? You just note that the 3 pi half is not. Okay, the cosine of the 3 pi half is 0, but the 3 pi half is not in the domain, is not, okay, it's not between 0 and pi. That's why you have to know that domain, and you see over here, 0 and pi. Just pick the correct solution. Okay, any question? Give us something with the negative, we give a couple of them. So we want to check this one. We want to know what is cosine inverse of negative radical 2 over 2. You say that's going to be the one. Again, you want to find an angle whose cosine is negative radical 2 over 2. Okay, negative radical 2 over 2. You know that the positive one, radical 2 over 2, is cosine of 45 degrees. And the cosine is negative in the second quadrant. That gives you 3 pi half. But it's easier to write the, okay, write the definition so that you're not going to miss it. You're going to say that, oh, I checked the cosine of negative radical 2 over 2. You may call it data. Okay, then you switch it. That tells you that the cosine of the data is negative radical 2 over 2. And remind you that you must be between 0 and pi. Then you go to the, okay, you go to the table, and that's it. Cosine is negative, it's going to be here. Negative radical 2 over 2 is 3 pi 4. Okay, 135 degrees. So the data is going to be 3 pi 4 or 135 degrees. Okay, this is the way you are going to know. You're going to check this one. Okay, any question? So some misleading information, or sometimes, tricky one, not misleading. You may be asked what is going to be the cosine inverse, a combination cosine inverse of the cosine inverse of the cosine of pi 12. Okay, we talked about it the other day. It's just like the reciprocal of a number. Okay, the inverse of the cosine. So if you talk about the reciprocal of the 5, the result is 5. But you got to be careful. You better check it. Okay, you better check it. So the result must be pi 12 here. But you better check with the definition that we have. Okay, so this is going to be the case. You are going to call this one data. So the cosine inverse of the cosine of the pi 12. Because the cosine of pi 12 is not the one that you memorize it, or you can see it on the table to be able to find it. Okay. So you are going to call this one, you call it data if you like. If you call it data, so that would be what? That would be cosine of the data is going to be equal to the cosine of the pi 12. Okay, cosine of the pi 12, and the data is going to be between 0 and pi. So that will be the fact that the pi is pi 12. Because the cosine are the same and they are in this range, so the data must be pi half. So if you go back and substitute, so that gives you the fact that the cosine inverse of the cosine of the pi 12, okay, is equal to the pi 12. Okay, so you are going to have some better one when we are going to give you more questions. Okay, any questions? So let's get the tangent, then we can start working all these together, okay? To give you, sometimes they, you may have a combination of these. Let me give you one of them, the one that takes a little bit more time. Okay, so that's one version. We give you this version for the, okay, the other night for the sine. So you got to be careful. Okay, so this is it. It takes a little bit more time. It's a very popular question. So we want to find the exact value of this one. Find, okay, find the exact value of, okay, you see, tangent of the cosine inverse. Cosine inverse of negative 1/3. Let's how handle this one. Again, the general method is we start from that inverse part. We're going to call this one something, alpha, x, y, z, whatever you like. Then to see what you are looking for. That's a general method that we're going to use. Okay, so the solution is going to be, check this one, give it a name. Okay, let this cosine, okay, cosine inverse of negative 1/3. You may call it theta if you like. So as soon as you do it, then you switch it. So that gives you cosine of theta is equal to the negative 1/3. And you know that your theta is between 0 and pi. Okay, so this means the theta is in the second quadrant because the cosine is negative. Okay, so your theta is going to be in the second quadrant. Make a note. Okay, so you are here. You are here. Let's go back. What do you want? You see, you want this one. So what is this one? So you note that. So you note that you are interested in the tangent. Tangent of what? Tangent of cosine inverse of negative 1/3. Now it's going to be changed to the tangent of the theta. So that's it. It's like the cosine of the theta is given to you. You see the cosine of the theta is given to you. They ask for the tangent of the theta. Okay, any question? Now we can go and find it. You know that we can get our right triangle, okay? So this is how we are going to arrive at the, so we say, oh, I have the cosine of theta, which is negative 1/3. Okay, get your right triangle. Okay, this is the one. You can use those formula, XR or etc. or just put it inside this triangle. Okay, that's going to be a theta. So it's a cosine, so it's going to be adjacent. You may call it a -1 if you like, and the 3 or just 1, doesn't matter. Okay, this is going to be 1 and this is going to be 3. So you have to take care of this side. You know there's going to be 9 minus 1, which is 8. So this side is going to be radical 8 or 2 radical 2. Any question? But we are interested in the tangent. Tangent of theta. You know that it's going to be negative. Okay, negative, what's the tangent? Tangent is going to be the opposite side. Okay, the opposite side over the adjacent one, which is equal to 1. Okay, so this is going to be negative radical 8, which is negative 2 radical 2. So there you are. The tangent of the theta is going to be negative 2 radical 2, and this is what you are looking for. Remember?
Wouldn't it be positive square root 8, not negative?
This one?
Yeah.
You see, this is 9 minus 1, which is 8. You take the square root, it's going to be radical 8.
Yeah, but how did you get the tangent theta equals negative?
Tangent is in the, theta is in the second quadrant.
Oh, okay.
Yeah, you have two choices. You may write this one negative and the 3, okay, negatives, then automatically we get the negative here, or just check the position. Okay. So what I did, I know the position. I know that the theta is here because the cosine is negative. So I'm in the second quadrant. So the tangent must be negative. Okay. So that's it. So the tangent of a cosine inverse of a negative 1/3 is going to be equal to the negative 2 radical 2. The final answer. Okay, any question? So that is the cosine inverse that we are going to have. Okay, there is a combination of these two together. We have it on the practice one.
Yes.
You know, but we talk about the combination when we get to that practice one. Let's get the tangent, then we are going to be ready for that idea. Okay, so this is going to be the situation that you are going to have. Okay, then I told you that what we do in calculus, we have there is a relationship between these two that we can take care of it right away, and that relationship, it must be somewhere in your book. Okay, let me try it. I think this is going to be a relationship. You see, remark. That's why we ignore the cosine inverse in calculus. Okay, the remark is, I think it's this one. You can prove that the sine inverse, okay, sine inverse of x is always equal to the pi half. Okay, it's going to be equal to the pi half, sorry, pi half, I think it's a minus cosine inverse of x. You see, that's a situation that we are going to know, we are going to have. That's why we don't use it when we get to the, okay, to this, we just use one of them to get these numbers. Okay, and it's not difficult to prove this one. You have to check the fact that if we have a sum of two, let me see how we did this one. You see, you know that if the sum of two angles, if you like, is going to be equal to the 90 degrees, okay, it's going to be 90 degrees. The sine of one of them is the same as the cosine of the other one. Let me try to see if I can prove it for you. That would be very useful. We may ask you to prove it. It's going to be true for the tangent as well. Okay, let's see if we can prove it. So what we do is we have to call one of them to be something to get to the other part. Okay, so let's see. Note that if you just call one of them, okay, note that if we call the sine inverse of, okay, the sine inverse of x to be something like equal to the theta, okay, if this is going to be the case, then what would happen? Then we have the sine inverse of x is equal to the theta, so that will tell us that x is equal to the sine of theta, but of course the theta is going to be between what is between negative pi half and the pi half. That is going to be your, okay, so that would be your x, if you like. So what you can do is, so this would be, so if you go back to the other part to get those numbers, to change it to the cosine. Okay, so this is going to be the case. So if you go back here, just something nice about this one that we can do it. This is the sign of the data. Okay, the sign of the data is the same as, you see, note that the sign of the data is the same as the cosine of its complement. The complement would be pi half minus pi half minus theta. So for example, you know, the sine of the 30 degrees is the same as the cosine of the 60 degrees. And these are going to be now the case that we are going to have. And so in this case, this is the sine, then you can change it. So this means, okay, so this simply means that the x is going to be equal to, okay, the x is going to be equal to the cosine of the pi half minus theta. Okay, and if you just use the inverse definition, so this means cosine inverse of x is equal to the pi half minus theta. Okay, I just switch it. But what is theta? Theta is sine inverse of x. So that gives you the fact that one of them, I did it the other way around, cosine of x is going to be pi half minus sine inverse of x. Or you switch it to the other side, we get the one that you are going to be interested in. This just for your information to know that. That's why in calculus, you see, this is, if you know the sine inverse, automatically you know the cosine inverse. That's why when we teach in calculus, we don't teach cosine inverse. We say, oh, you want to find cosine inverse? There you are, go and find it. So we focus on the sine inverse. When you are in calculus, sine inverse and the tan inverse only. Anything else, we can, we can find it. But in this course, you do it. But it's just a hint for future if you want to take more courses and see the relationship between these. Okay, any question? So they are, you put the pi half here. You cannot have anything else, because this is only for the pi half that when two, we call them cofactors over here. When two angles, the sum of two angles is 90 degrees, the sine of one of them is the cosine of the other one, and the cosine of the other one is sine of the other one. It's happened for the 30 degrees and the 60 degrees. For example, the sine of the 30 degrees is 1/2, and the cosine of the 60 degrees is 1/2. The tangent of the 30 degrees is radical 3/3. The cotan of the 60 degrees is radical 3/3. Okay, these are something nice if you like, but otherwise you'll be fine. But if you are in calculus, say, oh, because we have some tools, some ideas, we teach only the first one. We say, oh, look, there you are. You want cosine, we have it. So it depends on the application in future. But for the time being, it's just you're just using algebra rather than any properties of these functions. Okay, any question? So let's go to the tangent, the most popular one. You see, you need the sine inverse and the tangent inverse for application in science. Tangent, very popular. The shape of the graph, see the action of this inverse trigonometric function is coming naturally in some applications in science. That's why they like it quite a lot. So what is going to be the inverse of the, okay, you have to know both of them for future. So what is the inverse tangent function? So the last one that we're going to consider is the inverse tangent. You have to know only the domain that you have to restrict to get it. Okay, you know that it's not going to be again invertible in general. So you have to, it's not going to be satisfying the horizontal line test again. Okay, again, consider the graph of a tangent. So consider the graph of a tangent, graph of y equal to the tan x. You know, the tan is sine over cosine. So we have something that we call it asymptotes. So this is going to be in one period. The period of a tangent is pi. You see the way we are going to consider it is going to be between, okay, this is going to be 0, and this is going to be pi. We divide into 2. It's different from what we did with the sine and a cosine. Okay, and over here we go up to the negative pi, and we pick this one to be negative pi half. Tangent of the pi and the pi half are going to be infinity. So we say, you know, they are not defined, but they are going to be asymptote. These are going to be the lines that the graph would be eventually becomes, okay? And then we pick some points. The tangent of 0 is 0. Okay, the tangent of the pi 4 is 1. Then we can get the idea of the graph of the tangent. So this is going to be the graph of the tangent in between negative pi half and the pi half, which is the interval of interest. Again, horizontal lines, you see, horizontal lines will intersect the graph. In this, you know that if you want to check it, you are going to have a different format of this one. This would be repeated. Okay, this would be repeated over and over. So if we graph it in full details, then we'd be in trouble. Okay, you can have it. You know, I can extend it so that you will see it. This is, you have to go to the 3 pi half to get this situation again. Okay, if you go to the 3 pi half, if this is going to be 3 pi half, okay, then this situation would be repeated, which is not a good one. Okay, so this situation would be repeated. So it's not going to be a good one because the horizontal line would intersect the graph at more than one point. Okay, so that's why we pick only one of them to be able to do it. So as you can see, again, the tangent, the function y equal to the tangent of x has no inverse, on its natural domain. Natural domain is all real numbers. Okay, so we pick one interval. The famous interval is like the sine inverse, negative pi half and the pi half, you see. Negative pi half and pi half, you have only, you know, the horizontal lines would intersect the graph at one point only. So you are going to claim that, but it is invertible, has an inverse, invertible on this interval, on the interval of negative pi half and the pi half. You must know this interval. So for the sine inverse and the tangent inverse, both of them are the same. Negative pi half and the pi half. But for the cosine is 0 and pi. Okay, you must know this. So this is how we're going to define it. The definition of the, okay, the definition of the tangent inverse. This is it. So the inverse, as usual, the inverse, okay, inverse tangent function is going to be denoted by the definition. The notation is y equal to the tan inverse of x, and as usual, and it's defined by That's it, y equal to the tan inverse of x, if and only if you switch it, if and only if x is equal to the tan of y. Restriction, this y must be, okay, this is going to be when y is between pi half and the negative pi half. They don't like the infinity, so they don't usually write equal to. You can do it, it doesn't matter. But the crucial part is your x would be between negative infinity and positive infinity. So this means the domain of the tangent inverse is all real numbers. That's why they like it in science, because there is no restriction on the domain. Okay, so the domain of the tan inverse, is going to be, you see the domain of the function is going to be all real numbers, negative infinity and positive infinity. But the range of the inverse function, okay, the range is going to be negative pi half and the pi half. You see that's going to be the inverse function. And if you want to graph it, you just, the graph is going to be something like this one. So we just rotate that given graph, and this is going to be the case. You see, if you just turn it, that gives you the one that you have over here. Okay, if you do the other way around, you must get something like the one that we talk about it. Okay, so this is going to be the graph of the y equal to tan inverse of x. Okay, just the definitions. Again, as I told you, these functions, now you're just using it as a calculator. But in future, quite a lot. This would be, you just having something in science. This is going to be the mathematical design, the mathematical model of your whatever you are doing. Then you may be interested to find the maximum, the minimum, various property of this function. So it's just a definition. You don't have anything else for the time being. But in future, it's going to be quite a lot. So your job just finding those exact numbers, working with these some properties, and just a little bit of calculus. I'm going to give you an example at the end. Okay, any question? So make sure you know these restrictions. So the angles between negative pi half and the pi half, as soon as you switch it, and then in general, the domain is all real numbers. It's very, very famous function. Okay, we call it increasing function. You go from left to right, the function going up, up, up. Okay, so the things that you're going to do is just finding those exact value. And when you want to find the exact value of a negative number, you got to be careful. And this is the only point about it, really. Okay, example. We want to find the exact value. Find the exact value of each of these quantities. Okay, the first one, we go with the tan inverse of 1. You want to find a function whose, okay, you want to find a function whose tangent is equal to 1. You know that function, that angle is 45 degrees. Okay, but you can write it down if you like. If it's say 45, if we accept it, okay, the solution is going to be, so you let the tan inverse of 1 to be equal to the angle you are interested in. You switch it. That give a tangent of the data equal to 1, and data must be between, okay, negative pi half and the pi half. It's a tangent of 45 degrees, or the pi 4. Okay, so the data is going to be pi 4. You better bring that table that I gave you for the 30, okay, 60, 30 degrees, 60 degrees, and the pi 4. You need that for these type of ideas. Okay, any question? So that's the first one. When it is negative, you got to be very careful to pick a correct numbers. Some people, they miss this part. Okay, let's see what is special about this one. How about tan inverse of a negative radical 3? We want to find an angle whose tangent is negative radical 3. So you better change it to the format of a definition that we have. Okay, so what's going to be the solution? You are looking for an angle. Okay, so that angle is going to be theta. You switch it. So you switch tangent of theta. You want it to be negative radical 3. Okay, negative radical 3, and you are going to be between negative pi half. Okay, negative pi half and the pi half. You see the data is going to be in this interval. So you got to be careful to pick that number. You see, this is going to be a situation you're going to have. Okay, so that's going to be the pi half and the negative pi half. So you have to pick something here, okay, in this interval that you're going to have. Now, the tangent radical 3 for the positive one, the radical 3 is the tangent of the, okay, 60 degrees. So it's going to be tangent of the 60 degrees, which is here. You see, this is the tangent of 60 degrees for the positive one. Tangent would be negative for the first time the tangent is negative is in the second quadrant. So if you want to go with this one, this is 60 degree, which is 60 degrees. So the next one is 120. So 120, the tangent of 120 is negative radical 3. But remember, you cannot have 120.
No,
Because you must have here or here over here. And that would give you the result. This is a pi third. You know that this is going to be negative pi third. Okay. So again, you know, you can pick 300 if you like, because the angle 300, the tangent is radical 3, but you have to be between negative pi half and the pi half. So for the tangent, you have to work with the negative angles if you like. So for the negative radical 3, you have to pick the tangent to the theta to be negative pi third. Okay, so the tan inverse of a negative radical 3 is going to be negative pi third. Okay, don't go to the second quadrant for the negative numbers. Okay, because you must be in the first or the fourth. In the first and the fourth, so it's very easy. You just find the positive one, whatever it is, just make it into the negative going down to get these numbers. Okay, it's the same for the tangent inverse of a -1, if you like. And most of the people missed it. They give you 135 degrees, which is not. You have to, I write it down because it's very popular. And question?
Shouldn't it be negative pi over 6?
No, y pi over 6.
Because tangent of -3 is for sine over cosine, it's rad 3 over 2 over 1/2, which is 30 degrees, or pi over 6 radian.
No, you see, the radical 3 is what? I have the 60 degrees here. The tangent of 30 degrees is radical 3 over 3. You see the tangent of the pi 6 is radical 3 over 3. Because we switch it to get these numbers. But the tangent of, okay, the tangent of pi third is radical 3. You know that the tangent of this must be the same as the cotangent of the radical, cotangent of the pi 6.
Yeah, I'm just seeing it as what would be sine over cosine, but it's invert tangent. So it's different.
Yeah, you have to go with the tangent. That is easier. You see, because this is the one. You see, the cotan of pi 6 is what? That's a radical degree. And the cotan of the pi
Yeah.
6 is the same as the tangent of the, okay, the tangent of the pi third. That's how we did it. Okay. So let me give you a record to just keep this one because that's popular and the people missed it. Tangent inverse of -1. You see? You want to find the tangent, you want to find an angle whose tangent is -1. Most of the people, they say 3/4, which is correct. But remember, it's a tan inverse. There is a domain. You must pick anything between -π½ and the π². 3/435 degrees is not. So that would be, should be careful. So you have to pick the -π4, you see? So you are going to check this one first. You see data. Then the tangent of the data would be -1. But remember, there is a condition. You see, this is your condition. So this means you cannot pick 135 degrees. Okay, so again, that's the same thing. You see, you must be here or here. So for the positive one, it's a π4. So you get the -π4. So the data is -π4, not 135. Okay?
Yes.
So you got to be careful, especially for the tangent. For all the negative numbers for the tangent, this is the same thing that would happen. At the tangent and the sine inverse, not cosine. Because the cosine is negative in the second quadrant and the range is 0 and pi. So you're not going to miss it. But in the case of the sine inverse and the tangent inverse, since the domain is -π½ and the π², then you have to be either in the first part or the fourth one. So you have to pick negative angles for these two, okay? So this is what you shouldn't miss. Any question? Then the combinations are the same as we did before. They may give you this one with something else. So two possibilities for all of these. And we give a couple of questions, we put all of them together. So this is another possibilities. The case is you want to find what is the sine. Okay, find the exact value. Find this is the one that it's not only on the table. Then you have to use those triangles. Find the exact value of this is the one sine. Okay, sine of the tan inverse. Sine of the tan inverse of the 1/2. See, that's one. Again, as usual, we have to take care of this part first. You call it data. Then it's like finding sine of the data. Okay. So this is how we're going to start solution. We're going to suppose, okay, suppose the tan inverse of the 1/2. You call it data, okay? You switch it. So that you get tan of data equal to the 1/2. And make sure that your data is going to be what? Between -π½ and the π². So this means you are in the first quadrant because the tangent is positive. Okay, the tangent is positive. So this is it. So we are going to be in the first quadrant. Okay, now what do you want? Sine of the tan inverse, but now the sine of the, you see, the sine of the tan inverse of 1/2 would be the same as the tan sine of the theta. That's it. So it's like you have the tangent and you want to find the sine. So what we're going to do is, this is it, get the tangent. Okay, you have the tangent. Your tangent is 1/2, get your right triangle. Okay, this is going to be your right triangle. This is your theta. You have the tangent, opposite, adjacent. So we want to find this one. You know it's going to be a square of 1 is 1, a square of 2, 4. 4 and 1, 5. So that gives a radical 5. Any question? We're just using Pythagorean identity. 2 squared is 4. 1 squared is 1. 4 plus 1 is 5. The square root of 5, that gives you this one. Okay, but you want to find the sine. So the sine of theta. The sine of theta is positive, and it's going to be the opposite over the radical 5. And you rationalize it, radical 5 over 5, the final answer. So the sine inverse, the sine of the tan inverse of 1/2 is equal to the radical 5 over 5, and we are done. Okay, so this is how, as I told you, you cannot do anything else for the time being, but it's going to be quite a lot when we get, when we get to applying these formulas in future. Okay, any question? Now, the remark is that the notation, there is and kind of old notation for the sine. It's not for the sine inverse. You see in the classic form of the trigonometric function, they use something different for the inverse, very similar to the inverse. But it's going to be misleading, and we try to avoid it. But if you see it in this book, and sometimes we have it, so just give you a remark. That's an arc notation, if you like, okay? And that notation is going to be arc notation, okay? And this is going to be, note that, you see we can use the following notations. So the following notation can be used for inverse trigonometric function, inverse trigonometric function. It's used in the trigonometric in different places with different meaning, really. I try to avoid it in calculus because when we get to the function, we have some difficulty, but it's in your book now and you may have to use it. You see, instead of a sine inverse of x, they use this notation. They say arc sine. Arc, okay, that's it. Arc sine of x. So arc sine of x and the sine inverse is going to be the same thing. Okay, the cosine inverse of x is going to be arc cosine of x. Or the tangent inverse. I try to avoid it, but you just, just give you one. In this notation is something else. This is we use, to talk about when we get to the solving the equation, a trigonometric equation, that would be useful. Because there are two types. Sometimes this A is a capital A and sometimes a lowercase a, and they are going to be different. Okay, they are going to be different, but from the function definition point of view, that will cause some difficulty for us. But it is in your book, and if you see it, it's the same as the sine inverse. I prefer the sine inverse, and I don't support it for calculus, but it's not bad. We can use it, or when we want to solve so we may see a couple of them in your practice one. We just want you to know that this notation is also available to get these numbers. Okay, so this is going to be the situation we're going to have. Now, there is another type of application of these problems. Okay, let's just give you a break. We come back, we work on that practice one, so make sure you get everything. Then the other two problems that I want to talk about it are on the practice one. Then I give you more so you can practice yourself. Okay, so this is how much we need for these trigonometric functions. They are very easy to handle. That's why we just go with the sine inverse, okay, tan inverse, and the cosine inverse. The other may be used in future, okay, like especially secant inverse is popular, but we don't need it, you know, in trigonometric parts because they are not going to be behaving nicely like this one that you have. And as I told you, they are related to each other, so you don't need to know anything else. There is a relationship. If you know this, if you just know the sine inverse and the tangent inverse, you can write all of them. All the others can be written in terms of these two. So that's why we focus on these two only, the sine inverse and the tan inverse, because everything else can be, you know, can be derived from this. So that's why we are not going to talk about anything else. Okay, give you any question?
No.
Give you 10 minutes, we come back, we go over that, check that practice test. There are quite a lot on that one. Just want to make sure we get everything on that, okay?